Pressure. Solid pressure is the force acting normally per unit area of the surface. Pressure is equal to the force or load or weight divided by the area. Pressure is F over A. The unit of pressure is Newton per meter squared. Liquid pressure depends on 1. The density of the liquid. Pressure is directly proportional to the density. 2. The pressure of a liquid also depends on the depth of the liquid. Pressure is directly proportional to the depth of the liquid. 3. The acceleration due to gravity represented by small letter g. Pressure of a liquid is directly proportional to the acceleration due to gravity. Generally, liquid pressure is given by P equal to the depth times the density of the liquid times the acceleration due to gravity. This is our equation 2. Pressure in a liquid is exerted in all directions at any point in the liquid. Also, liquid pressure is the same at the same level in a liquid. The U-tube manometer is used to measure gas pressure. This is a simplified version of the U-tube manometer with this end going to the gas chamber. So the liquid inside here could be water, most times it's mercury. If it is mercury, the pressure of the gas exerted on the liquid is equal to the atmospheric pressure plus the excess pressure above the atmosphere. In the equation terms, we have gas pressure is atmospheric pressure plus the difference in the level of the liquid on both arms of the manometer. That's H. So if the liquid is mercury, the atmospheric pressure is 760 millimeter mercury. Then the difference in height between the two levels should also be millimeters. Then if we sum them up, that will give us the pressure of the gas. Example 1. The height at which the atmosphere ceases to exist is about 80 kilometers. If the atmospheric pressure on the ground level is 760 millimeter mercury, the pressure at the height of 20 kilometers above the ground is dash. A. 570 millimeter mercury. B. 480 millimeter mercury. C. 380 millimeter mercury, and D, 190 millimeter mercury. Pressure is directly proportional to the depth or height above the ground. P is directly proportional to height. P is equal to constant times height. The pressure divided by the height is always constant, meaning P1 divided by H1 should give us P2 divided by height H2. So the pressure is 760 millimeter mercury when the height is 80 kilometers. We are looking for the pressure P2 when the height is 20 kilometers. So if we cross multiply 80 P2 will give me 760 times 20. P2 will give 760 times 20 over 80. The pressure at that height is 190 millimeter mercury. By this solution, option D is correct. Example 2. Which of these statements are true of liquid pressure. That's pressure in liquids. I, pressure acts equally in all directions. I, pressure decreases with depth. I, pressure at the same level of a liquid is the same. IV, pressure is dependent on the cross-sectional area of the barometer tube. Option A, I and I only. B, I and I only. C, I and IV only. D, I and IV. To answer example 2, we look at the properties listed from I to IV again with respect to liquid pressure. I, pressure acts equally in all directions. Correct. I is correct. Pressure decreases with depth. That is wrong. Pressure is directly proportional to the depth of the liquid, so it increases with depth. I is wrong. Three, pressure at the same level of a liquid is the same. Correct. The third one is equally correct. Pressure is the same at the same level of a liquid. Number 4, pressure is dependent on the cross-sectional area of the barometer tube. The pressure in a liquid does not depend on the area of the container. So, option IV is wrong. By this, option A, which is I and I is correct. Option A is correct. Example 3. In the diagram below, if the atmospheric pressure is 760 mm mercury, the pressure in the chamber G is dash. Here is chamber, possibly with a gas inside. The level of the mercury inside the manometer arms is indicated. The long arm, 10 centimeters. The short arm, 3 cm. You are asked to find the pressure of the gas. Option A, 660 millimeters mercury. B, 690 millimeter. C, 830 millimeter, and D, 860 millimeter. Solution. Pressure in the chamber pressure PC is equal to atmospheric pressure plus excess pressure above the atmospheric pressure. So chamber pressure will give us 760 millimeters plus the excess pressure represented by the height, difference in height. H is 10 minus 3 centimeters. H is 7 centimeters, which is 70 millimeters. Therefore, chamber pressure in the chamber will give me 760 millimeters plus 70 millimeters. Pressure in the chamber will give 830 millimeter mercury. By this Solution option C is correct. Example 4. The atmospheric pressure due to water is 1.3 times 10 raised to power 6 Newton per meter square. What is the total pressure at the bottom of an ocean 10 meter deep? Provided is the density of water 1000 kilogram per meter cube and acceleration due to gravity 10 meter per second square. The options are A. 1.3 times 10 raised to power 7 Newton per meter square, B. 1.4 times 10 raised to power 6 Newton per meter square, C. 1.4 times 10 raised to power 5 Newton per meter square, D. 1.0 times 10 raised to power 6 Newton per meter square. The solution to this example is as follows. The total pressure is equal to the atmospheric pressure plus pressure due to water. We are given the atmospheric pressure of the atmosphere to be 1.3 times 10 raised to power 6 Newton per meter square. We are also provided with information to calculate water pressure from the water in the ocean. And this is equal to the depth times the density of water times acceleration due to gravity. Water pressure will give us 10 times 1000 times 10 Newton per meter square. Pressure of the water is 1 times 10 raised to power 5 Newton per meter square. Having obtained that, total pressure will give us 1.3 times 10 raised to power 6 plus 1 times 10 raised to power 5. And this will give us 1.4 times 10 raised to power 6 Newton per meter square. Option B is correct.